Hi guys, what we're going to look at today then is some double angle formulae. So the first one we're going to look at is a kind of simpler way, or how we could rewrite this equation. So we've already looked at the identity. Sine A plus B is the same as sine A cos B plus cos A sine B. Now, what we're going to look at now, or what we're going to do in this formula, is say, well, what happens if A and B are the same? So if we let B be the same as angle A, so they're both exactly the same size, then hopefully you'll see that sort of this first bit here, the sine A plus B, is going to become sine of 2A's. A plus B would now be 2A's. This bit's going to be sine A cos A. And the second bit's going to be cos A sine A. And hopefully then you'll see that that simplifies down to have a new identity, that sine of 2A is the same as 2 sine A cos A. So your first question, the first thing I want you to do is to, by doing a similar thing with the cos equation, can you prove that cos of 2A is equivalent to cos squared A minus sine squared A? So have a look at that first. I want to pause the video, have a go at that one. And then once you've done that, can you also then, from there, this bit should be easy, from that, can you show in that case that this must be the same as cos squared A minus 1, and it's also equivalent to 1 minus 2 sine squared A. And once you've done it with cos, then have a go exactly the same. Try to find an expression for tan 2A by doing the same thing. Hopefully, if you've done that one, have a go at actually proving this, your answer should come out as 2 tan A over 1 minus tan squared A. And these are really useful, but if you know where they come from, you can derive them anyway from these addition formulae that are given to you in the formula booklet. So you probably don't need to learn them, but it's nice that you can see where they come from. Okay, let's just look at a couple of quick examples then. So for the first one, if I have something like 1 plus cos 4 theta, and I want to rewrite that in a more simple way. Okay, so what I could do is use a double angle formula to rewrite the cos 4 theta as 2 cos squared 2 theta minus 1. And that would simplify to become 2 cos squared 2 theta. Okay, second example then. This time, if you're told that cos x is 3/4 and that x is in between 180 degrees and 360 degrees. Oh, that's a terrible x, sorry. And I want you to find the exact, so that means keep it in its exact form with the roots in it, value of, and we're going to look at what the exact value of sine 2x would be. So if you were given that question, what we're going to think about is how we can sort of work out the other ratios in terms of this value. So if we know that cos x is 3/4, it's going to be x. So cos x is 3/4, so that's going to be a 3 and a 4. And using a bit of Pythagoras, this side is then going to be root 7. Thinking about what size our angle is actually going to be, if it's between, so we know that the angle here that we're looking at is in between 180 and 360, so it's somewhere down here. And we also know from up here that the cosine of it is positive. then we know it must be in this quadrant. So our angle must be bigger than 270 but less than 360. So the angle that we're looking for is in here. So cosine's positive, but sine and tan are both negative. So I can say straight from this triangle here that sine of x must be root 7 over 4, minus root 7 over 4 even, and that tan of x must be minus root 7 over, sorry, my mistake, that should say root 7 over 3 for that one. So we've got all of our three ratios, cos, sine and tan. We just now need to put it into this sine 2x formula. So from the very first thing we looked at, we now know that sine 2x is equivalent to 2 sine x cos x. And I've already worked out the values of sine x and cos x on the previous slide. So I can now say that in this case, sine 2x is equal to 2 times minus root 7 over 4, which is sine x, and cos x will be 3 over 4. And if we multiply that out, we're going to end up with minus 3 root 7 over 8. And that's our exact value for sine of 2x. Okay, so a few questions for you to have a go at then on this. If we want to take out a piece of paper or jot this down somewhere, it's page 115. Oh, actually, it might not be in your book because you've got the old book. Look up exercise 7b. It could be on a different page. It's most likely to be on a different page for you. So it's exercise 7b that we're looking at. And I'd like you to have a look at questions. We'll do one. Let's just do part G and H in that one, from question 1. And then if you look at question 2, let's just do part C in that one. And then if you have a look at question 3, let's do H and I from there. And then when you finish that one, let's have a look at questions 4, 5 and 6. So those questions, make your own notes from the video just follow previous to this on the double angle formula, and I will see you all on Wednesday afternoon.